Hey guys, I hope you had a great week. Today we're going to be going over some example problems that I've pulled out and adjusted from Chapter 8, end of chapter problems. And so I've changed the numbers, so these will not be the answers in the end of chapter problems, but the steps will be about the same. In our first example, we're looking at a research project on ginkgo biloba. We're going to take a look first at our formulas for both the standard error and our z. The standard error is equal to standard deviation divided by the square root of n. So in this example, we'll have 21, which is our standard deviation, divided by the square root of 49. So that's 21 divided by 7, and that equals 3. Next, for our z-score formula, we'll take the sample mean and minus the population mean and divide that by the standard error. So in this case, we'll have 92 minus 70 and divide it by 3, which gives us 7.3 repeating. Now, this is not a number you're really going to see. This would be so far in the extreme tail that it won't even show up on a unit normal table. It's just the result that I came up with. But generally, your z is going to be less than 4. After we find our z, we're going to take a look at what our critical threshold is before we can make a determination whether to accept or reject or not reject the null. And when in the homework, when you take the slider and move it back and forth, which is based on your alpha level. So if a two-tailed test is at 0.10, then you're going to have 90% in the body and 5% in each tail, because your alpha level, an alpha level of 0.10 is 10% are in the extreme regions. Then you have to take a look at the z that you came up with and determine if it's in a tail or not. So in a one-tail test, your whole 10% will be in one tail, but in a two-tail test, your 10% will be split up, divided by 2, and 5% will be on each side. So in this case, we're going to reject the null because our z is in the far reaches of the regions of the tail. So in the orange region is your extreme values. And if your number comes up in the orange region, then you reject the null. If it's in the blue region, then you don't reject the null, because it might be because of the treatment, but it might not be. So one of the other things I wanted to mention again is that these numbers are different than the numbers in your homework. So these are not going to be the same answers that you come up with. I just took the numbers and changed them. So sometimes when you have an experiment, you have two groups that are showing different scores than everybody else, and or each other. So you want to analyze them and to determine whether they're statistically significant or not. So for the females, we're going to calculate them separately from the males, and our standard error will end up being 1.2 divided by 7, which is 0.17. And then we'll find the female's z, which is the female's sample mean minus the population mean divided by the female standard error. Next, we'll find the standard error for just the males. So we'll take the standard deviation divided by the male's n number, by the square root of the male's n number. We'll come up with 0.2. Then the males will have their own mean, which is the male's sample mean minus the population mean, divided by the standard error. And we'll come up with a z value of 3.2. Since in this example our alpha level is 0.01, only 1% of our scores are going to be in the extreme tail, and 99% of our values are going to be in the body. And when we move our slider, we see that our critical Z is 2.33. Since the Z we came up with for the males is 3.2, that's beyond 2.33, so we will reject the null because the males drank significantly more than average. For the females, though, we want to know if they drank significantly less than average. So our critical Z is going to be negative 2.33, and our female Z is negative 3.53, which is well beyond negative 2.33. So we're also going to reject that null because they drank significantly less than average. In our next example, we're going to have to determine the power of the hypothesis test, which is the probability that the test will correctly reject a false null hypothesis. Our first step will be to find our standard error, which is the standard deviation divided by the square root of n. In this case, it'll be 20 divided by the square root of 16, which is 20 divided by 4, which will equal 5. In our next step, we're going to use our Z formula, except we already know Z because we have an alpha level of 0.05 in a two-tailed test, which gives us a critical region of plus or minus 1.96. We have the population mean and we have the standard error, but we don't know what the sample mean is, so we're going to have to solve for m. Since our hypothesized population mean is expected to be lower, we're going to start with our negative value for our Z critical, which is negative 1.96. And we'll set that equal to the sample mean minus the hypothesized population mean of 240 and divide that by our standard error of 5. And we'll multiply each side by 5 to cancel our 5 on the bottom out. And we end up with a negative 9.8 equals m minus 240. And we'll add 240 to each side. We come up with our sample mean number. And I made a mistake here and I put hypothesized population mean next to m, and that's not really what it is. So we're just going to ignore that in an effort to actually get this video out. Next, we're going to find the treatment effect for the sample mean. So we have the sample mean of 240 minus the 30 milliseconds that the reaction time is expected to drop. We come up with 210. So now we've got to find a new Z. And our new Z is going to be our sample mean minus the hypothesized population mean, with the expected drop divided by our standard error that we found in part 1. We come up with 4.04. I wanted to point out once again, this number is not going to be in a unit normal table because unit normal tables don't go above 4. But anything below 4, you would look on your unit normal table to find the probability. And we'll switch over to a unit normal table to see what the value is if it was something else, like 3.75. So 3.70, your probability would be 0.9999 that the scores are going to be below the Z that you found. I hope going through these problems has helped. If you have any other questions, just ask me on the discussion board, and have a great week. Take care. Good luck.